Hello and welcome to math. And today we're going to learn how to simplify radicals. Okay, to simplify radicals, we're going to need to know our perfect squares. So take a second, pause the video, see if you can fill in the perfect squares right here, the first 20 perfect squares. See if you can do it. Go ahead and pause the video and try it. Okay, hopefully you paused the video and hopefully you wrote down your perfect squares. If you didn't, here are the perfect squares, the first 20 perfect squares. We have 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, 256, 289, 324, 361, and 400. Okay, so these are perfect squares because 400 is a perfect square because the factors of 400 are 20, right? 20 times 20 gives me 400. It's the product or the answer to a whole number times itself, right? So 400 is a perfect square because 20 times 20 gives me 400. 16 is a perfect square because 4 times 4 gives me 16, right? Okay, so those are our perfect squares. Those are going to be super important to know, and they're going to be super important and helpful here because we're going to simplify radicals by using these perfect squares. All right, so to simplify a radical, we can simplify radicals by finding a factor that is a perfect square. Okay, so what we're going to do is there's going to be a number under the radical. A radical is just a square root sign. This is a radical. That's a radical. All right, that's a square root sign. And we're going to see the number underneath the radical. We're going to find a factor that's a perfect square. And what we want to do is we want to find the biggest perfect square that is a factor of the number under the radical. Okay? So then what we're going to do is we're going to take the square root of the perfect square and we're going to place that in front of the radical sign. And the radical sign is that radical sign. It's a square root sign. Okay? The remaining factor remains under the radical. All right? So we're going to start with a number underneath this radical. And then we're going to figure out what a factor of that is that's a perfect square. And then we're going to remove that perfect square and keep whatever is not a perfect square underneath the radical. All right? We're going to do an example here in a second. Okay, so we're looking for perfect squares. So like the square root of 4, 4 is a perfect square because 2 times 2 will give me the square root of 4. But when we write our answer, we just pull out that 2, right? So that's what we're doing here. So if I have the square root of 20, I got to figure out which of these perfect squares is a factor of 20, right? So 20, what can be divided into 20? Well, all these numbers down here are too big. I'm going to change my color here so it's easier to see. 121, 100, right? None of these are going to go inside of 20. They're way bigger than 20, right? So I know the smallest one it could possibly be would be 16. But if you think about it, 16 can't evenly go into 20, right? It's too big. All right, so what about 9? Can 20 be divided by 9? Well, it can, but it'll give me a decimal answer, right? Because the factors of 9 are 9, 18, 27, right? So that doesn't work. So what about 4? Does 4 work? Yes, 4 works because 20 divided by 4 is 5. So what I'm going to do is I'm going to rewrite this. Instead of square root of 20, I'm going to rewrite it as square root of 4 times 5. All right, so now I have my perfect square. So now I can take that perfect square and I can pull this perfect square out. I know the square root of 4, right? The square root of 4 is 2. I don't know this square root of 5. So that square root of 5 stays underneath the radical. And I know this looks weird. I know this doesn't look like a final answer, but this is a final answer. This is the most simplified radical we can get. We can't simplify that square root of 5 anymore. The reason why we do this is because if I put this in a calculator, let me open up a calculator here. Desmos. If I open up a calculator and I put square root of 20, it gives me this big long decimal, right? So all square roots that are not perfect squares will give you a irrational number. And an irrational number is a number that goes on forever and doesn't repeat. Kind of like pi, right? So anytime we write an irrational number as a decimal, we're rounding it. So therefore, it's not the most accurate and most correct way of writing it, right? So we want the most correct way. If we want to keep this the most correct way, we have to simplify the radical and we keep it like this. So you can see I can check this by typing in that 2 square root of 5 and I should get the same decimal answer, and I do. So that's an easy way to check to see if you got this right. Okay, let's go on to the next one. So I got square root of 50. So square root of 50, I'm going to go through here. These are way too big, way too big. 49, that's like 50. That's not going to go into it. 36, that's not going to divide into 50. But 25 will, right? 25 will. So square root of 50, I can rewrite as 25 times 2, because 25 times 2 will get me to 50. So then I'm going to take my square root that I know, this perfect square of 25, and I'm going to pull that out. Right? So the square root of 25 is 5. This square root here, this 2, I don't know the square root of. I can't do that, right? That's not a perfect square. So that's just going to stay square root 2, and then there's my answer, 5 square root 2. Like I said, it looks weird. Doesn't look like it should be the final answer, but it is. And we can check our work right here. Square root of 50. You can even check the 25 times 2. 25 times 2, right? And then I can do, we had 5 square root 2. And you can see they're all the same decimal answer, so I know I got that correct. All right, let's try this next one. Square root of 128. We always want to look for the biggest perfect square that can go inside of that, all right? So 121 is not going to work. That's too close. The 100 is not going to work. That's not going to divide into 128. Same with 81, because 81 times 2 would be 162, right? So that's not going to work. 64 should work, though. Let's try 64. If I do 128 divided by 64, I get 2, right? So that would work. So I'm going to rewrite this as 64 times 2. And then now I can pull out my perfect square. I'm going to pull out this perfect square of 64 and pull that outside the radical. So the square root of 64 is 8. So that's going to come out as 8. And this 2, I don't know the square root of, so that just stays square root 2. And once again, I can check my work. I can type all 3 of those things in and see if I'm right. Right? So I have square root of 128. I have square root of 64 times 2. And I have 8 square root 2. And I should get the same decimal answer for all 3, and I do. So that's an easy way to check your work. We know we got that one right. Okay? One last one, number 99. What's the biggest square root that can go into 99? Let's see here. The 121 is way too big. 100 is way too big. 81 is way too big. 64 is way too big. 49 is close. 49 times 2 would be 98. So that's close. So it's going to be something up here. It's going to be 36 or above, up this way, right? So let's try these different ones and see which one can go into 99. So let's see here. Clear this out. 99 divided by 36. Does that work? No, that gives me a decimal answer. So it doesn't work. 25 is not going to be it, because 25 would be 25, 50, 75, 100, and that's not any of those, right? So what about 16? Can 16 go in? Nope, 16 gives me a decimal answer. So my next one's 9, and I know 9 works, because 9 times 11 gives me 99, right? But you always want to make sure you have the biggest perfect square that goes into it, right? So 9 times 11 gives me 99. That 9 is a perfect square, so I can pull this 9 out from underneath my radical by taking the square root of it, and the square root of 9 is 3. I can't take the square root of this 11 because it's not a perfect square, so that just stays under the radical sign, and we have 3 times the square root of 11. Let's check our work. Let's see how we did. Let's see, square root 99, boom, and then we have 3 square root 11. We get the same decimal answers, so I know I got it right. We're good to go, okay? So, in theory, in short, here's what we have to do. When you have a number under a radical sign, underneath a square root sign that is not a perfect square, like square root of 20, what you do is you find the biggest perfect square that can go inside of that can divide into that number, that is a factor of that number. So, like for this one, we had 4, right? So you find the biggest square root that can go, perfect square that can go inside of that. You take your perfect square and you take that out from underneath the radical by doing the square root. The other factor that multiplies to the perfect square to get the original number stays inside the radical. And then you can always check your work on Desmos. You can always check your work on Desmos, just like how we did here. We type in the original and we type in our answer, and you should get the same decimal answer. And that should be a way to check your work to see if you got it right. Okay? All right, that's our notes for today. I hope you understand. If you don't, ask a teacher. We're going to practice a lot today in class, and I will catch you next time. Bye-bye.